Let me introduce myself. I'm Aliaksandr Valialkin. I'm a CTO at VictoriaMetrics, and I currently work actively on VictoriaLogs. And my talk will be about VictoriaLogs, how to solve challenges with log filtering and analytics. Let's start. In this talk, I will use VictoriaLogs and another system which will be shown soon. What is VictoriaLogs? If you don't know, it's log storage from VictoriaMetrics. It is very easy to set up and operate, like VictoriaMetrics. It runs optimally without any additional configuration out of the box on any hardware, starting from Raspberry Pi to a machine with hundreds of CPU cores and terabytes of memory. It is very lightweight and fast. For instance, single node VictoriaLogs can replace Elasticsearch cluster with 30 nodes, because single node version of VictoriaLogs uses up to 30 times less memory than Elasticsearch, and up to 15 times less disk space than Elasticsearch. And VictoriaLogs also provides its own query language, which is named LogSQL. It is designed to be very simple to start with and too simple to learn it. And from another point, it is very powerful query language which supports fast full text search, and also it supports fast analytics. I'll show you later how it works. And another component which will be shown in this talk, it's a very new component which has been published a few weeks ago. It's VLogs CLI or Vlogscli. This is an interactive command line tool for querying VictoriaLogs. This tool supports query history, so you can move between queries which you already executed and searching these queries in the same way as usually you do this in Unix shells. It also supports scrolling of arbitrary large responses in the same way as less command in Unix shells does. So it just shows you one page of your response, and after that you can scroll down, up your response and investigate it and search in this response, and then exit if you finished investigating this response. And I will show you later how it works. And Vlogscli also supports canceling queries which take too much time to execute, because when you investigate logs, it's quite common to hit some queries which are too heavy to execute, and it's better to cancel them and refine them. And the Vlogscli supports canceling query execution by pressing just Ctrl+C, as in usual command line tools. And when you cancel query execution, this means that the query instantly is cancelled at VictoriaLogs side. So VictoriaLogs stops executing this query and frees up all the resources occupied by this query. And Vlogscli supports live tailing, like tail F command in Unix. You can investigate the logs with additional filters. So you type some filters and type some data transformations for these filters, and then you can look at logs matching these filters with these data transformations in real time. So how to analyze big number of logs? The first thing which you probably will start is to estimate the number of logs to analyze. Let's look at VictoriaLogs instance, which runs internally in VictoriaMetrics company in Kubernetes cluster, internal cluster, and collects all the logs from this internal cluster. And during over the last year, let's look at how many logs this VictoriaLogs collected for 1 year, and we can make this online, like in demo via LogSQL. Let's try it to do. Here you can look just at the screenshot of executing some queries, and we'll try to execute these queries online via LogSQL. So we start this Vlogscli binary and provide this binary with some header cookie. This just authorization cookie for allowing access to our internal VictoriaLogs component. And then we provide some URL for this VictoriaLogs component and start. So we are in the shell for Vlogscli, and let's look at the number of logs in this system. We perform this query. This query just what it does. We say that let's select all the logs. So this is a star. We can just look at these logs if we want. It's okay to perform this query without any worries, because as I said, we can cancel this query at any time just by pressing Q here. So this query has been finished, and we can calculate the number of logs, total number of logs in the system by performing this query. And as you can see, the total number of logs is around 2 billion. Let's calculate the number of logs during the last 5 minutes. For instance, it shows the number of 70,000 for 1 day, for 1 week, for 1 year. So as you can see, this query is executed very fast, and it returns the number of logs, the total number of logs in the system for less than a second. It's okay. Okay. And what is the system which runs this VictoriaLogs? Right now, VictoriaLogs runs only on a single node. There is no yet cluster version, and the cluster version will be available soon. So this VictoriaLogs instance runs on a single node version, and this VictoriaLogs instance runs in Kubernetes with the CPU limit is 4. This means that it can use only 4 CPU cores, and the memory limit is around 13 or 14 gigabytes. 14 gigabytes. So, as I already shown you in this demo, you can look at this query, which selects all the logs for the last year and counts the number of logs, is executed in 1 second. And this query is executed, as I said, on VictoriaLogs instance, single node instance, which runs on a 4 CPU core host with 14 gigabytes of memory. And the next slide shows the size of logs which were ingested over the last year into our test cluster, test VictoriaLogs instance. You can see that these are just metrics exposed by VictoriaLogs instance, and you can see that the amounts of ingested logs is 2.5 terabytes. At the same time, these ingested logs are compressed into 45 gigabytes. So these logs occupy 45 gigabytes on disk. And this means that the compression ratio is higher than 50. So you just divide 2.5 terabytes by 45 gigabytes and get this compression ratio. So we started with estimating the amounts of logs which you need to analyze. And the next step is to look at recent log samples in order to understand what is ingested into your log system. You can just execute a query with some filter on time, which selects logs over last few minutes, few seconds. So in this case, this query selects logs over the last 5 minutes. Let's execute this query in online. So we execute this query online, and we can look through these logs and scroll through these logs as you want, and search in these logs some strings, as you do when you use less command, and exit from this less command when you finished. Okay. So what we selected here? This this example of what Vlogscli shows you when you execute query. The next line after you press enter in the query shows the actual parsed query by LogSQL, and it is advised to look at this actual parsed query because it can be different compared to what you typed, and you need to look at the actual query when you need to debug something, if something goes wrong with this query. And the next line also shows the query execution time. In this case, you can see that the query is executed in 100 milliseconds. What are other lines? Other lines show you every log entries, and every log entry is shown as a separate JSON object. This JSON object contains a message field, which is named _MSG. This is a log message. And log entry also contains a timestamp, which is _time for this log. This log entry also contains stream fields. This is _stream and _stream ID, which shows you the ID of the source of logs. It is recommended to attribute every source of logs which are ingested into VictoriaLogs with a separate log stream in order to simplify first analysis of these logs, and this also improves query performance and improves efficiency of data compression. So it's advised to configure these stream IDs with log fields, which uniquely identify every log stream. You can read about this later in documentation. Let's go further. And there are other fields which are just log fields, and these log fields can be arbitrary. You can ingest any log entries with any set of log fields, and you don't need to provide any configuration to VictoriaLogs. VictoriaLogs automatically accepts all these log fields and automatically indexes all these log fields and automatically performs always performing fast full search over all these log fields. So if you look at this example, you will see that this screen contains only a single log entry, and this is because this log entry contains a lot of log fields, and this is not very convenient to investigate log messages in this case, because it takes too much vertical space. And Vlogscli allows you improving this situation. You can switch to compact mode. This is \C. When you switch to compact mode, then Vlogscli shows you every log entry in more compact form. Like in this case, you can see that in this case, every log line shows you a single log entry for the last 5 minutes. And this log entry, we type in this query that please select only log message field and drop other fields. And in this case, you can see that every log line contains just log message, and it is much easier to investigate such logs. Let's try performing this in Vlogscli. I forgot. I just switched to compact mode, but forgot filtering out other log fields. So such in this case, every line contains all the fields, and it's not very convenient to investigate them. Let's limit our search to only message field. So it's much better right now. So every line is just a regular log line. We can add timestamp field in order to understand the particular timestamp for every log line. You can see that every log line contains a timestamp right now in the first at the beginning, and after that it contains log message. So far so good. When we investigate logs, like in this case, you can see that there is a lot of noise log lines, and it will be better to filter out these log lines before continue investigating logs. For instance, on this screen, you can see that log lines contain a lot of messages with node get with the node word, for instance. We can copy this word and then update our query at minus node. Minus node here, and enter again. And right now we see that logs do not contain this minus word. So these logs are just filtered out, and we can improve our refine our logs investigation with additional filters, like in this case. For instance, in this case, we just filter logs for the last 1 minute, and these logs should not contain info word, and these logs should not contain error details phrase, which is put into quotes. And this particular query, just sorts all the output logs by timestamp, because by default, VictoriaLogs doesn't sort responses by timestamp because of performance reasons. Because if you try to sort big response by timestamp, this means that you need select all these logs, billions of logs potentially, and then sort them. And then after that, after the sorting is completed, you can return these logs to the client who requested these logs. And this sorting of billions of logs can take a lot of time and can take a lot of memory. That's why, by default, VictoriaLogs doesn't sort logs by time. But if you create a query which selects comparatively low number of logs, for instance, millions, then it's easier to just add this sort pipe and get logs in the sorted order by time or by other field. So as I said before, in this case, you will see in compact form, you will see timestamps, and also you can see log messages. And every line contains a single log entry with timestamp and log message. What to do next when you investigated recently ingested logs, applied some filters, refined this query, and what to decide next? The next thing is quite common, is to figure out the top sources of these logs. This can be performed with this top command. So this query just selects all the logs, 2 billion of logs, and then performs this top command on these logs. This top command selects top 5 most frequently seen values for Kubernetes container name log field. In other words, it selects top 5 containers, container names, which generated the most of logs over the whole lifetime of this VictoriaLogs instance. So let's perform this query in our interactive Vlogscli. Oh, it takes some time. Let's wait whether it will. Oh, it has been finished. Okay, so it finished in 11 seconds and showed you top container names which generated the top of logs. The first Fluent bit container generated more than 400 million of logs, and the second container also is Fluent bit, also generated more than 400 million of logs. So, by the way, you can see that this query has been executed in 11 seconds because why it's too long. Because it needed to scan to read the data from disk, because this data wasn't cached in memory. And if we try executing this query next time, it should be executed much faster, because yeah, it is executed in less than 2 seconds, because this query could read data from operating system cache. VictoriaLogs doesn't cache anything for this query. It just selects all the data from disk, but in the second case, it could read this data which has been cached by operating system. So this query is executed much faster. So we figured out, and the next slide shows that you can select top log sources by multiple log fields, not by single log field. For instance, this query select top log sources by a set of 3 log fields: Kubernetes container name, Kubernetes pod name, and Kubernetes pod ID. So what to do next? The next is usually you need to drill down into particular log source. For instance, let's drill down to our Kubernetes pod ID, which generated the most of logs. We can see on the last screen, on this screen, that the first Kubernetes container name is Argo CD application controller, and pod ID something long string which ends on 268. So let's dive into this particular Kubernetes pod ID logs. Let's look at logs for this particular Kubernetes pod ID for the last day. Let's try executing this query here. So the query is executed almost instantly, but it is hard to figure out what is going here, because I'm in this compact mode right now. And let's switch to default multi-line JSON mode and execute the query again. And it's much easier to read query results right now. So if we look at this query results, we can see that the message field here contains some garbage, but it's not garbage, it's log FMT formatted message, which just contains field name, equal value, and this field name and equal values are separated by white space. And how to parse this? VictoriaLogs supports this unpack log FMT command, which allows you parsing these messages, and it unpacks this log message and puts every log field into a separate log field with the prefix specified here. In this case, the prefix is x dot. And you can see in the log output that this log fields are extracted from log message. What to do next? From this case, you can see that there are some log messages, and this parsed log messages, log FMT fields contain a level field. Let's look at some stats over this level field. What we do here, we just perform the query, which selects all the logs for the last day for this particular pod ID, then unpacks this log FMT message, and then calculates stats by level and counts the number of logs by each level, and sorts the number of logs by the number of logs, the output by the number of logs. And as you can see in the response, the most of logs contain level info. It's 8,000 logs for the last day, and only 4 logs for the last day contain a level error. So we can investigate this level error logs. Focus on this level error logs. How we can do this? We can just add additional filter after unpacking a log filter, log FMT fields. Just add filter. Please show me only log messages with level field equal to error. You can investigate this, and you can see this the query. In this case, the query is executed quite slow. You can see that the query selects the logs for the last day and for the last day here. And the number of logs, as from the previous screen, you can see that the total number of logs was around 1 million. If you sum all these numbers, you can get 1 million. And the performance of this query is around 7 seconds. So it doesn't look good, and we can improve it. Okay, that's about improvement this query. We'll talk about this later. And in this, actually, this query shows how it can be improved. We just move this filter at the early stage before we parse these logs. So we filter this level error in plain text, put this filter in front of the query before performing other calculations. And this allows you improving the performance of this query by 3 times in this case. And this query calculates all the I forgot something. If you look at the previous query, was executed over the last day. Here, filter on last day, and it took 7 seconds. And this screen shows that the query is executed over the last year with this filter log error, level error, and the query time is 2.5 seconds. So it is much, much faster compared to the previous query. And this query selects, so we can see that the number of log messages for this particular pod ID with level error phrase over the last year is only 59. And we can see that this stats comment selects the minimum and maximum time for this log level, this log messages. You can see that these log messages were generated only during September and October this year. So how about searching for the needle in the haystack? That's a quite common practice when you investigate large amounts of logs. And for instance, you want to find some trace ID, user ID, IP address in large volumes of logs. And VictoriaLogs is optimized for this particular case. It uses Bloom filters, which allows skipping blocks of data which don't contain the string you search. And this improves query performance a lot, contrary to Grafana. So let's start. When you look at the previous logs, you could see that some logs contain this TG spam phrase. And this phrase, it has been appeared that the phrase is quite rare in logs. So we can calculate select all the logs with this TJ spam over big amounts of logs, like 2 billions. And this query is executed very fast. In this case, you can see that the query executed in 1.6 seconds. And we can count the total number of logs with this keyword over all the logs which are stored in this VictoriaLogs database, which are around 2 billion. And you can see that the query performance is also outstanding. You could remember that the number of logs is around 2 billion, and the total size of uncompressed logs is more than 2.5 terabytes. So VictoriaLogs, which is executed on a machine with 4 CPU cores and 14 gigabytes of RAM, could execute this query over all the logs, well, 2.5 terabytes in less than 3 seconds. And how about searching for pairs in all the logs? We can execute this query here. It's also very rare word in our logs, and it is executed. It should be executed quite fast, and not so fast as on the screenshot. Let's wait. Oh yeah, it is executed in 14 seconds, and let's execute it again. As I said, right now, VictoriaLogs searches for logs in searches for the data information in memory. Oh, so it's not so good to compare it to the screen. On the screen, it's almost 3 times better. I don't know why. Probably there is some noisy neighbor when at the machine. Oh, okay. So the third time, the query performance is even better than on this slide. So we can see that the number of log entries with pairs word in log message is, where is this, is 50 across all these 2 billions of logs. And the query performance is also quite good. We can look at this particular logs if you want. Just replace this count with fields message. No, let's just perform this query, which type this pairs word and see what this query is. So we found something. Where is the pairs? let's search for queries with this less common. You can see highlighted queries here in the log message, directly in the log message. Some log messages contain some queries. Okay, let's go further. Let's look at analytics of unstructured logs. We investigated structured logs before, and what about unstructured logs? For instance, let's investigate some log samples from Grafana in this case. And these log samples, let's select log samples which contain this user ID phrase. We can see this user ID here. And this user ID is contained in directly in log message. How to calculate the stats for top users with different logs. Top users which generated the most of logs, user IDs. Let's execute this query. So what does this query do? We select all the logs for Grafana with this particular string, and then extract user ID from this particular string into user ID field. And after that, we calculate the top 5 user ID values. And you can see that the most popular user ID is 0, and the next is 4, 6, 10, 12. Let's look at another example at the same Grafana logs. We select all Grafana logs with the duration string. You can see example, for instance, here, durations. And the durations is in milliseconds, seconds, and so on. Let's calculate the average duration per some message. Let's look. So what does this query do? It performs this unpack log fmt command because we could not notice that this Grafana logs contain in reality the log fmt messages, and we can unpack them, logs from log fields from them, and then perform some mass calculations on the duration field. You can see that you can divide this duration by 1 second in order to get duration in seconds. And then perform some stats calculations, which calculate duration in seconds, average duration in seconds per each message field, which is also extracted from this log fmt formatted messages. And you can see results here. And after that, this duration seconds fields, log messages were rounded into milliseconds and sorted in descending order of these seconds. And the results are here. You can see that the longest duration is for update check failed message. The average duration is 12 seconds. And the lowest duration is for some migration successfully executed message. And the duration is 4 milliseconds. And you can see the number of logs per each duration. In the last case, it's around 2,000 logs. So, do I have some time? Yeah, I have time. Okay, that's good. Let's look at the performance optimization tips for VictoriaLogs. The first tip is to use the most specific filters when you perform some queries. For example, in this case, you can select logs for the last 7 days, which contain a service account word. And in the first case, the query execution time is less than half second. And in the second case, you just use some less specific filter, such as level. The level word is contained in much more log messages compared to service account filter. And after that, you perform this count calculation, conditional count calculation, which is supported by VictoriaLogs. You just count the number of logs which contain this service account word in them after the filtering. And you can see that in the second case, the query performance is much worse. It's almost 9 times slower. So the first rule of thumb is to put the most specific words and phrases in filters, initially in filters in the query. This improves query performance a lot. The second tip is to use the most specific time filter, because when you select logs over big periods of times, then VictoriaLogs obviously need to scan all these logs to calculate something. In this example, you can see that the query performance for 1 day is much better than the query performance for 1,000 days, for instance, for the same query, for the same filters. The third performance optimization tip is to use the most specific stream filter. The stream filter is a filter on log streams, which I was talking about in the beginning of presentation. It's quite complex theme. I recommend you reading the documentation, but let's look at this. The first query uses just wildcard stream filter on Kubernetes container name field and selects all the logs which contain service account word. And you can see the query performance is 4 seconds. And in the second example, we just narrowed down this filtering on stream, and we just put this operator filter instead of wildcard filter, and you get instant improvement in the query performance by 10 times in this case. The next optimization tip is to use prefer word and phrase filters instead of regex filters wherever you can, because word and phrase filters are much faster usually, because they can use this Bloom filters, take advantage of Bloom filters. And in this case, you can see that the regular query over 7 days is executed in 300 milliseconds. And the same query with the regex filter, this is tilde in front of some word or phrase, means that this word or phrase is regex match. And this query is executed in more than 10 times slower. And the results are the same, almost the same, because these queries are executed online, and probably some service account log messages fit here. And the last optimization technique, what is this? Is it okay? Okay. The last optimization technique is to prefer case-sensitive filters over case-insensitive filters. LogSQL supports case-insensitive filters, but it is not recommended to use them due to the same reasons, because due to the same reasons why you should not use regex filters, because they are slow and cannot use Bloom filters. And in this case, you can see that it is better if you know that some your logs contain some words with different cases. Then it is better to enumerate every such word with different case, with OR operator instead of using this case-insensitive filter. You can see that the first query is executed 10 times faster than the second query. And the last performance optimization tip is to prefer full phrase filters instead of prefix filters. VictoriaLogs supports prefix filters, but it is not recommended using it if you want achieving the most performance. In this case, you use the regular query with the word filter, and in the second case, we use prefix filter. The prefix filter is just some word or phrase in quotes followed by a star. This means that please find everything with this word and phrase followed by anything. And as you can see, the second query is also almost 10 times slower than the first query, due to the same reasons, because the second query cannot use Bloom filters. Let's look at some interesting stats, non-trivial queries, which can be executed in VictoriaLogs. This query calculates the pod lifetime across all the logs. This selects all the logs and then calculates stats by every pod. It counts the number of log lines at every pod, selects the minimum time for logs for every pod, maximum time for logs of every pod, then filters everything with Kubernetes pod ID, which contains non-zero, non-empty string, because there are some logs with empty strings, so I decided to filter out them, and then calculate the difference between max time and min time in days, rounded by tens, and then sorts this results by lifetime days in descending order and returns only the first three results. You can see that the query performance is quite good, 3.5 seconds over 2 billion of logs. And you can see that the pods, pods with the longest life live for 60.5 days. 60.5. And these pods were living in the previous year. As you can see, the lifetime of the pods from the previous year. So the previous pods from the previous year were have good lifetimes. And what about the average lifetime and the median lifetime and so on? Let's calculate this information here. So we calculate this median lifetime of pods, 80% of lifetime of pods, 90% of lifetime of pods, and the maximum lifetime. Maximum lifetime we already know, it's 60 days. And what about other things? You can see that the median lifetime of pods is 2.4 hours. It's just regular Kubernetes where every pod restarts very frequently. And 80% of pods live less than 4.4 days. And 90% of pods live less than 10.7 days. So that's just typical Kubernetes installation where everything in the flux. Let's look at another query which calculates containers with the biggest share of logs containing the word error. So what do we do here? We select all the logs for the last day and calculate stats grouped by Kubernetes container name. We calculate the number of logs. We calculate the number of logs with error word, this conditional stats calculation. and then divide the number of logs with error words by the number of total logs, round it to 1/100, and sort this error share in descending order in order to get top 10 containers which generate most of logs with error. As you can see, results are not good here. So these containers, 8 first containers, generate just logs only with errors. And they do not generate info logs or warning logs. It's not good. It's probably we need to improve the situation, to look at these logs and fix something. And you can see that the last 2 containers generate 50% of logs, around 50% of logs. Yeah, logs with error word. So that's all. You can. I recommend you start running this VictoriaLogs, start playing with it, start playing with LogSQL query language, and doing this with Vlogs CLI tool, which is very useful to do. And if you prefer web UI, then we have an answer for you. VictoriaLogs provides web UI, so you can use web UI, and also VictoriaLogs provides Grafana plugin. You can use this Grafana plugin, but it is not. It contains some raw pages, I would say. So you can start using it. I recommend you filing issues, bug reports, and feature requests, and over time we'll make it very good, great. Yeah, that's all. Questions? Yeah.
Thank you for the presentation.
Good evening. Thank you for the presentation. I have a first question. I right now use Elasticsearch. If I wish to migrate to VictoriaLogs, do you have some procedure to follow? Do you have something to help me move my stack from Elasticsearch to VictoriaLogs in documentation maybe or something?
Yeah. So VictoriaLogs supports data ingestion for Elasticsearch format, so you can use the same log shippers as you use for shipping logs into Elasticsearch. You can just reconfigure them to ship logs to VictoriaLogs.
Just in targets. Just a new endpoint and everything.
Yeah, you just change endpoint in this log shippers, and that's all. Not that's all. It is recommended to properly set up this stream log filters. Stream log fields, as I said before. So it is recommended reading documentation about stream logs, log streams, and in order to understand how to configure it properly. But it's not difficult. As for data migration for existing data, we have no such tool right now. Probably we'll create such tool in the future, like VMCTL tool for VictoriaMetrics.
Thank you.
Thank you.
You switch to. So, I can repeat your question if you.
Yeah. Thank you for your presentation. I tried the Grafana plugin for. Okay. So first of all, thank you. I tried the Grafana plugin for Victoria Logs, and the thing I would really like to have is when we have pipes and we do a count. So that's where it doesn't support any aggregation or let's say I have a query that that pipes and that does a simple count for some keyword that I found, but it doesn't give the expected values. So when is that feature? I checked the GitHub page, and when is that feature going to uh,
Implemented?
be shipped with the VictoriaLogs?
Okay, I understood your probably I correctly understood your question. So the question was that Grafana plugin for VictoriaLogs doesn't support this count pipes or different pipes, stats pipes from VictoriaLogs, or it doesn't support it properly in an expected way. Is this a question? And the question is when a VictoriaLogs plugin for Grafana will support these pipes? Yeah.
Yeah.
Yeah. If I have no answer to this question right now because Grafana plugin for VictoriaLogs is developed by other team members, and I'd recommend you filing bug reports, filing feature requests, and taking active participation in this feature requests and bug reports, and this will improve the possibility and the time when this feature or bug report will be fixed or the feature will be implemented.
Thank you. I have one more question. In some of the query, I wanted to ask, is sort by some column and then applying a limit, is this better than top or by that column? So which one will perform better?
Yeah, under the hood, the top command pipe uses the same code as sort by with the limit. So the answer is that it doesn't matter, and the top pipe is shorter to write, so it is recommended to use instead of calculating some stats and then sorting and then limiting by the stats.
Okay, thank you.
Thanks for your presentation. I have a little question about scaling VictoriaLogs. Actually, in my society, we have 5 cluster of using Loki, who is actually pretty bad at querying. And we have 100 terabytes of log approximately on each one for 1 year. Or we can scale efficiently with VictoriaLogs in this type of case.
Sorry, you said you have 1 petabyte of logs or terabyte?
Terabyte.
It's a very low number. You can see that in our toy cluster, VictoriaLogs instance, we store 2 and 5 terabytes of logs, and it can scan all these logs at a very fast speed, and in the steady state, it uses just a few hundred of megabytes of memory and just 10% or less than 10% of CPU for data ingestion, for indexing of these logs, which are ingested here. So if you have such low number of logs, such low amounts of logs, such as a few terabytes, then you can use VictoriaLogs freely on some cheap hardware, such as which contains a few CPU cores and a few gigabytes of memory. It will work very fast. And on the other end of spectrum, if you have hundreds of terabytes or petabytes of logs, then you can also try using a single node VictoriaMetrics or VictoriaLogs instance. But in this case, obviously, you need much more CPU cores on this host and much more memory in order to perform this queries over these amounts of logs at faster speeds. because VictoriaLogs performance scales automatically with the available resources. If you add more CPU cores, then performance of queries will improve proportionally to the number of added CPU cores. If you add more memory, this means that more data can be cached by operating system in file cache, and this means that it will improve performance over for queries over logs which feed this operating system cache. So if you usually perform queries over logs which occupy hundreds of gigabytes or terabytes memory, then it is better to have to run VictoriaLogs on instance with hundreds of gigabytes or terabytes of memory in order to improve performance of such queries. But it is doable. You can just VictoriaLogs scales perfectly with available resources such as CPU, memory, and disk I/O resources. So just use proper resources for your needs. And as I said, if you have only a few terabytes of logs, then you can run VictoriaLogs on one CPU, on 2 CPU, and with a few gigabytes of memory, and it will work very good.
Okay, thanks.
Maybe one last very small question. How big have you tried to run a VictoriaLog instance for now? Like, what's the biggest scale you have achieved while doing testing or development?
No, we this in our roadmap. We need obviously to push to try pushing limits of single node VictoriaLogs. Try to run it on node with hundreds of CPU cores and terabytes of memory and see how it works. But we didn't conduct such tests yet. And I would recommend you, if you have enough resources, then I would recommend you trying this test on yourself and then publishing this information or sharing this information with us.
Yeah, we do have a big service. We will give it a try for sure because that's something we like. We really like to do. Okay, we'll if that's okay. We have more questions. We need to go a bit fast, and then Aliaksandr will also be available after to answer any further question.
Okay, thank you for the talk. I have a question about performance optimization. You mentioned about prefixes, that whole word like service account is faster than service account asterisk. But what happens is if I ask something like service acc, will it find me nothing, or it will find all these service accounts?
Yeah, by default, VictoriaLogs indexes words. And the word definition is that there's some sequence of chars separated by white spaces or some separators. So for the answer to your question, if you search for service egg, for instance, and you want to find the service account word, then VictoriaLogs will not return you logs with the service account. You need to put this asterisk after service acc in order to enable this prefix search, and after that it will find these logs, but it will find it at a much lower speed.
Thank you.